The next topic we're going to cover here are the various ways to create streams in Java 8. And this comes back to a question we were just talking about with respect to splitterators. How do you create a stream? Well, one way to do it is to use a splitterator, but there's other ways to do it as well. So we're going to talk about various factory methods that Java 8 provides in order to manufacture streams out of different things. So streams can be obtained in various ways. By the way, I had way too much fun finding beautiful pictures of streams, right? So here's the most common way of doing this, is basically using factory methods from a Java collection. So if you recall that the collection interface in Java has two methods, so everybody gets it by default, stream and parallel stream. So let's assume that we have a list of words, which we get through some means like taking an array and turning it into a list. We could then create a list of, whoops, that's not correct. That should be stream of search results, which we would get by saying, oh, I take it back. No. Imagine there's more going on here that eventually turns it back into a list. So we say words to find.stream, we'll turn this into a stream, we'll turn this list into a stream, and then a bunch of things could happen, and eventually we would end up with a list of search results. So that's how to do it. You've all seen this before, pretty much a no-brainer. Here's the other way to do it, is to use parallel stream. So stream, parallel stream, it's really simple to change that. There's another approach that's worth knowing about, which is you could start out by saying, words defined.stream, and so by default it'll become sequential. And then at any point along the way, before you hit the terminal operation in the stream, you can say dot parallel. And what this does is a little bit murky. I'll explain it to you, but if you look at it at first, you might think, oh gosh, does this mean that everything from here to here runs sequentially, and then after we see the dot parallel call, everything from there to the end runs in parallel? You might think that, because that would be intuitive. Unfortunately, that's not the way it works. So whenever you call dot parallel in a stream, in a stream pipeline, at that point, unless you say dot sequential, this whole thing is a parallel stream. So whichever call, dot parallel, dot sequential, occurs last in a stream is what will be used to determine the concurrency semantics of the stream. So in this case, we could just say dot parallel, and at that point, it'll become a parallel stream when the terminal operation is hit. Yes?
But the only reason is if we call is the default.
Yeah, good question. Yes. Well, yes. So if you had said, dot parallel stream instead of dot stream, and then said dot sequential, I would think you were insane. But you could do it, and that would then have the effect of turning off the parallel stream directive and making it a sequential stream again. Probably this is a good time to explain why the heck would you ever need this, right? The reason you would need this ability is if you want to be able to dynamically decide at runtime whether your stream should be parallel or sequential. So you'll notice if you call, let's go back up here, if you say dot stream or dot parallel stream, that is kind of baked into the code, right? This thing is a parallel stream, this thing is a sequential stream, end of story. So what if you want to dynamically decide, based on some kind of conditional decision, what kind of stream it's going to be? And I'll show you some examples of this later, this technique later. But basically, what you can do is you could have something where you would, say, if I want to make this parallel, then take your stream object and say dot parallel on it. Otherwise, it just remains sequential. So the most useful thing to do is to use dot parallel to conditionally decide to enable parallelism on a stream that occurs based on runtime decisions rather than baking it into your syntax. Yeah?
So by that logic, could you also do dot parallel stream and then if dynamic parallel stream?
Yep. Yes, so you could also do the reverse. You could start out with a parallel stream, and then if you decided for whatever reason you wanted to do it sequentially, you could go ahead and ratchet it back to be sequential.
Is one better than the other?
No, I mean it's actually identical. The performance behavior would be identical. It would be a lot weirder, to my mind, to start out with a parallel stream and then turn it sequential. most normally you'd start it with sequential, and then if for some reason it's like, oh, I know that I'm on a 8-core machine, then I'm going to turn parallel on. Even that's a little bit esoteric. I mostly honestly have used this for test purposes to demonstrate how running things in parallel cause bugs. That's usually how I've used it in my code to test stuff. Yeah. Good question. So what is the question here is what are the semantics of saying dot parallel? When dot parallel, let's assume for sake of argument we do something like this. We start out with dot stream, then we have 25 intermediate operations doing map and filter and flat map and whatever. And then we say, we have to rearrange the code slightly, but the effect would be if we want to run in parallel, then make the stream parallel, right? Then none of the stuff will run sequentially. When the terminal operation is hit, the stream takes a look and says, what was the last decision? Was it parallel? Was it sequential? And if it's parallel, then from the very beginning when the stream starts to execute, it's all running in parallel. And that's because nothing happens until the terminal operation is hit. So remember we talked about how all these intermediate operations are lazy. And I show you like the kitten that's sleeping and stuff like that. That's because they don't do anything until the terminal operation is hit. When a terminal operation is hit, then the stream starts to run, and if dot parallel was the last thing, or if it was the last decision point about parallel versus sequential, then the whole thing starts out being parallel. That's very subtle, and that's why I'm explaining it, because it's not at all intuitive how it actually works. Another way to do things is to convert you can take an array and turn it into a stream. So here's one way to do this. You can say arrays.stream. Remember, arrays is one of those funky utility classes, and it goes ahead and takes an array. In this case, it's just a simple array with 5 strings in it, and it converts that array into a stream of strings. And then we could go ahead and use the for each operation to either print out with a lambda expression or print it out with a method reference. Just showing you what you could do. The interesting part here really is this part. We can convert an array into a stream. There's also static factory methods. So stream has a factory method called of. If you recall, of is almost always used to make something. It's a factory. So in this case, we're going to make a stream out of an array. So once again, stream.of array. And then you can go ahead and do something with the stream that we get. And I guess I should say this is S, not stream. Which is better? Kind of depends what you're trying to do. I kind of like the stream of variant, but they're really essentially equivalent here. You can do stream of, or you could also do arrays.stream. They do the same thing. Not really a good reason to choose one or the other. Here's another static factory method. This is a really funky, interesting example. This is stream.iterate. So stream is the interface. .iterate is a method that's used to create an infinite-sized stream. So this stream will go on forever until you tell it to stop. So let's take a look at how we might do this. This particular example is going to generate and print the first 100 Fibonacci numbers using a stream. So what does it do? We take the first value, or first parameter to iterate is like the base condition. So that's going to make ourselves a new big integer array having 2 elements, both of which are the value 1. And then the next method here, so that's what this does. Then the next parameter here is a lambda expression, which says, given a big integer array, go ahead and compute the next value by taking the first item as the new big integer we're making, and then adding the first item to the second item. Take the second item and then make that the first element in the array, and then add the first element to the second element and make that the next value. So we're just making this other one. It's basically doing the Fibonacci sequence, right? They're adding the things together. And this is basically a generator. It's going to keep doing this forever. And then we basically go ahead and we strip out the results to just give back a single value. and we limit this to the first 100 of these things. So even though iterate will effectively generate an infinite size stream, we're going to limit it to only going up to 100. And then at the end of that, we'll have a stream of 100 Fibonacci numbers in order, and we go ahead and we print out the result. There's a bunch of other methods that have been retrofitted into Java in various places to do cool things. So here's an example where you can take a file name and you can go ahead and essentially get all of the lines in the file. And so lines will create a stream of lines in a file. And so in this particular example, we're taking a file name. The name of the method is print lines. We take a file name. We create a new buffered reader. And we set this buffered reader to essentially get every line in the file as a stream of lines. And then for each line in the stream of lines, we're going to print it out. So that's kind of cool. So the for each is used to print things out. Here's another variant of this. There's another class called files, which, as the name implies, is also another one of these sort of utility classes. And it's got a method called lines. And once again, we take a file name, and we get all the lines in the file, and we go ahead and print them out. Here's another interesting one. This is particularly useful for various test programs where you want to generate random numbers. So what we can do here is we can create a new random object, and we can say ints. And this will go ahead and it will, come on. You make a new random number object, and you use the ints method to generate a stream, an infinite stream of random numbers between 0 and 100. So this is the range of the numbers. So 0 to 100, we generate an infinite stream of random ints between those values. In our particular case, we limit it to only 50 of them, and we print the result out. So you can start to see that limit is a way of being able to tell a stream that's otherwise an infinite stream, don't go forever. Stop after a certain count. We'll talk later about sort of stateful operations and short circuit operations, and limit is an example of a short circuit operation because it stops a stream after a certain point. Okay. There's a bunch of other stream-bearing methods that have been integrated into the JDK. For example, I've mentioned this one to you before. It's pretty cool. This is a way of taking a, making a regular expression that can be used to split something. So in this particular case, we're going to give this split as stream method a new string that contains all the bytes in a file. So we're going to go out and we're going to read all the bytes in a file, and we're going to give back a new string that contains all the bytes, and then we're going to pass in a splitter, which is our regular expression, and this will return a stream of strings that work by taking the string that's passed here as the parameter, which contains all the bytes in the file, and turning that into a stream split by the regular expression. That's a really powerful, very concise way of splitting a file into a stream of strings based on some criteria. And I actually use that in a lot of my test programs for the works of Shakespeare. So I have one giant file that contains all the works of Shakespeare, and I simply put the @ sign at the beginning of every new work of Shakespeare, because obviously Shakespeare didn't include the @ sign in his text, right? So the @ sign is a unique value that I stick between or at the front of each of the names of the plays. So I have a giant file with a bunch of @ signs separating the works of Shakespeare. And so I simply do something like this. I just go ahead and take all the work of Shakespeare as one giant byte stream, as a string, and then I split it by the @ sign, and voila, I have a stream of strings where every string is a work of Shakespeare. So just illustrating how that could be used. There's some other cool things here. There's a method called generate, which you can use to generate a bunch of things. So in this particular case, we're going to generate an infinite set of tree maps, and then we're going to limit it to the first 100, and we're going to collect that into a list. So we end up with a list of tree maps, and we control what a tree map is. We make a tree map. Tree map's a class I would have written, for example. And we're going to make 100 tree maps, which could be useful for something. Okay, let's see. I think that's about that. You'll see later when we talk about some of the other Java 8 programs that this kind of an idiom turns out to be very useful, again, for test cases, that we're trying to generate test cases for various things. Okay, so that is the end of the factory methods discussion.